All right, can one of you remind us what we learnt about in the last class? Can someone remind us? Hello? Please, what did we talk about in the last class? Bishop, please reduce your distance. Rina and Kristen, I can see the both of you are in this class, so can I get a response from you?
Organic chemistry.
Are you serious? Organic chemistry. That was like 2 or 3 classes ago. Oh, were you not in the last class? The one we had last Wednesday. Okay. All right. So because a lot of time has been spent today and this class has to end by 8, let's just go into what we have today. Okay, so your WAEC yellow paper meant for your school or teacher is already out. So your teacher from school probably has given you little 1 or 2 details about what you're expecting in your examination. Okay. And based on the paper,
Huh?
you said, did you, are you saying something? I said your teacher has probably told you 1 or 2 of what you're to be expecting in your examination. Okay, so you're you're likely going to be having um question on titration. Okay, and this time around it's going to be an acid-base titration process. Okay, one of the reagents that was mentioned in the yellow paper. I'm talking about this year's examination, your exam that you're writing by on the 20th. So you should take seriously what you'll be learning today. Okay, it's like general knowledge. I think you have already know some of these things before now. So titration, okay, where we'll be dealing with the acid and base reagent. So the acid for this year, based on the paper, is H2SO4, okay, and the base is sodium hydroxide, okay, and also we'll be doing qualitative analysis, testing for salt, okay. So we'll be making use of lead to, okay, is it carbonate or nitric? Carbonate, and starch, lead 2 and starch. Okay, all this while we've been talking about quantitative volumetric analysis. Okay, we'll talk about titration. Now there's the qualitative one, the other one, that one where you make use of a test where you'll be given some instructions, and when you have observation, and then you have your conclusion or inference rather. Okay, this is also another part of your practical. So these are the things you have to we might be able to cover today. If not, we'll continue on Wednesday. Okay, but let's start with the titration parts. So I hope the two of you are with your writing materials. Okay, since we already know that we are dealing with sodium hydroxide and tetraoxosulfate, okay, you would be given the steps on what to do. Okay, your practical manual or question might be telling you you're going to be using your acid as your titrant. That is what is going to be in the burette. Or you're going to be using your base, you're going to be pipetting your acid, or you're going to be pipetting your base. Whatever instruction they're going to be giving to you is what you take note of. But most of the time, okay, or some of the time, we tend to make use of our acid in the burette. So whichever one, you just have to be keen to the instruction. Okay, so we are going to be, in fact, let from the manual. mm, okay. So we're going to be attempting some questions, okay, because of time. We would be taking these, okay, to be the standard, since we already know we are dealing with this acid and this base, okay. And based on the yellow paper, inferences that is also made on purity of our acid. So we're also going to be talking about that as well. So at the end of the day, remember I told you from the last class that the major thing we get to, the major essence of the whole acid-base titration process, for us to get our average volume, okay, usually of the titrant, and that will help us to know an unknown concentration, to be able to calculate for concentration. So that's what we're going to be focusing on today. And so this is our what's the language I would use now? This is our postulated, or I assumed question, okay, for this year's WIEC based on the information on the yellow paper. Okay, so when we see questions like this, the first thing is to identify what and what are participating in this whole process. Now, we have identified that it is an acid and a base. So that is to say, the major first step to take is to write a balanced equation. Since we are dealing with acid and base, we know it's a neutralization process, okay? And so this neutralization process will be H2SO4 plus our sodium hydroxide to give us salt and water. I'm teaching what you're expecting in this year's WIEC. So when you have questions, please raise up your hand and ask them. Okay, plus water. So the next thing is to balance your equation, of course. So to balance this, we have our hydrogen is in the reactant is 2, 3, and the product is not up to that. So let us also see our sodium is balanced. What am I putting? I'm mixing it up. This is not what we're supposed to have in our product. This is our salt, please. Okay, we're not dealing with HCl. So our SO4 is also SO4 in the reactant. So we'll be treating it as a single unit. Okay, and then our sodium is 1 in the reactant and 2 in the product. So we have to make it 2 in the reactant, right? And then our hydrogen now in the reactant is now 4, and in the product is just 2. So we have to include 2 here. 2 times 2 to give us 4 now is balanced. And then our oxygen is also balanced because the oxygen here is the same as the oxygen here, right? So now the first thing is done. we've gotten our balanced equation. So you may want to write down this whole question. I hope you have all written it down already because I will be scrolling away. Now, some formulas we should take note of. I believe I already wrote it down in your in one of the previous classes. Okay. Formulas we should be taking note of is this our general formula. Okay, one of the formulas is number of moles equals to mass divided by molar mass. Another formula is finding concentration and volume, concentration of base and volume of base to give us number of mole of acid, number of mole of base. Now, another formula we can be taking note of is the formula for molar concentration. That molar concentration is equals to mass concentration divided by molar mass. Now, these are key formulas we will be using for this question. Okay. Now, one thing we should take note of is when these formulas come in. The unit for concentration, okay, can be mole per dm cube. It can also be gram per dm cube. And it can also be mole per liter. Now, mole per liter is like the same quantity as mole per dm cube because liter is the same value of the same value as dm cube. Okay, and we can also see something like gram per centimeters cube. We know we now have to convert the centimeters to decimeter if our answers should be in decimeter. Now, when are we going to use any of this? When we are talking about is he asking a question? Lucas, please mute your mic. Oh, okay. When we talk about mole per dm cube, we're talking about concentration in mole. So we call that molar concentration. But when we are thinking about gram per dm cube, we're talking about concentration in mass. You know, gram is the unit for mass, mole is the unit for number of moles. Okay. So now we would make use of, in this first formula, okay. Ah, this boy should mute his mic. I don't know if it's in the car. Lucas, please mute your mic. Please, as we were saying, so this concentration here in this first formula, okay, concentration of acid, concentration of base, okay, is usually when concentration is mole per dm cube. Now, please, this class is chemistry class. Someone is asking. But when we talk about gram per dm cube, we are directly talking about mass concentration, not molar concentration. And so we would use the formula, this second formula, okay, when we are given concentration to be in gram per dm cube. Winners, why are you tearing? What's the problem? You don't
I do not
understand?
understand, ma. I don't- As with
What
the
don't you
beginning.
understand? Wonderful. Okay. Now, okay, let us go to the beginning. In fact, let me leave all these formula things. When we get there, we'll talk about it. Just take note of these formulas, okay? Look at the question on the boards. These old things written in black is the question, okay? Now, the question says, A is a solution prepared by dissolving. Hmm? Ashua? What first part? I'm starting all over again.
Okay, ma.
I said, yeah, I'm reading the question. I said, A is a solution prepared by dissolving 3.8 gram of H2SO4 in 400 centimeters cube of solution. Don't fret by all these many values given to you. Now B is sodium hydroxide, okay? Sodium hydroxide solution containing 4 gram per dm cube of sodium hydroxide, okay? Now, using methyl orange as indicator, okay, it depends on your school also if you are going to carry out the titration process, and also what WAEC asks you to use. Titrate solution A against a 20 centimeters cube or 25 centimeters cube portion of solution B. Now, solution A, we know it is the acid. That means if they say titrate A against B, it means that titrate. Now, we know that in titration, something is going to be in the burette, right? And then there's something that will be in the conical flask. What is in the conical flask? Okay, this was gotten from what we sucked out from the pipette. That's what we put inside this conical flask. Now, when they say titrate this against that, what is in the burette is what is titrating against. Okay, so when they say titrate A against B, it means A is what is in the burette, okay, and B is what is in the pipette. All right. So that is to say, it is we are releasing the burette to pour. We are pouring from the burette to the pipette. So we are pouring from A to B. That is A is titrating against B for us to get a color change. All right. That is to say, whatever readings we are getting from the burette is the readings. Burette is a volumetric tool, so the volume from the burette is what we are going to use to know our volume of our acid, because it is acid that is in the burette based on this our question now, okay? Now, B, how do we know the volume that is in B? The volume that is in B is going to be the volume of the pipette, what we sucked out to put inside our conical flask, okay? So it's already actually in this question. So since they said in the question, just watch the question and it gives you all the clue. Since they say in the question, titrate solution A against this or this portion of B, that means we have been given the volume of B. Now they are saying 20 centimeters cube or 25 centimeters cube because burettes can be, sorry, pipettes. No pipettes. That's tiny thing that we use to suck the acid or base. They have 1 mark portion here, right? Now the pipettes can be in 20 centimeters cube or 25 centimeters cube, depending on the one your school is using. But I feel like the more common one is the 25 centimeters cube pipette. So we're going to be sticking with 25. We can't use the 2. So let us just try to ignore this one. Okay, so that is to say we are titrating solution A, which is our acid from the burette, against 25 centimeters cube pipette. So repeat the titration 3 times, record your readings. These are the things where your question paper is going to be telling you, okay? Now, use the experiment results to answer the following questions. Now, the first question is obviously and most likely the average volume of your acid. Remember, your acid is the A, and your acid is what is in the burette. So we must find the average volume. That is the oga pata pata that will help us to know the solve any other thing in the question. So now, since we are not carrying out an actual experiment right now and right here, we're going to be formulating our burette readings. Okay, and mind you, we don't just formulate and give any number. Okay, for this year's WAEC, even though you people are used to writing burette reading to be 21 point this, 22 point this, all this kind of value, it's going to be less than that. Why is it so? I'm going to tell you shortly. Now, this is what we are going to be using as our readings. Okay, so um I hope I'm able to manage space enough. So let me, please, you people should be jotting down, no, because this will be very handy for your exams. Now we are computing our readings now. Okay, now we have our final, this is how you write it, final reading in centimeters cube. Then we have our initial reading. Please write it in full reading. Me, I'm managing space in centimeters cube. And then we have our total title value. Okay, you can just write it like that. And then in our column, you can make this in the column or in the row. Depends on you. In the column, we can decide to start with rough. Okay, very advisable, so that your examiner will know that you know what you're doing. So then we have our first title, our second title, and our third title. Let me finish this line. Okay, now for our rough, so we have 13.6. These are formulated values that you might also find useful yourself. Okay, and then for our first, we have 12.50, and let's say we have 0.00, and let's say we have 20.50. And then here, let's say we have 25.10, we have 12.50, and then we have 12.60. Then we have 12.50, 0.00, and 12.50. Now, explanation. We are trying to find the average volume of acid. When we look at this whole thing, if we look at our balanced equation, we will see that the ratio of acid to base, okay, is let's say this is acid and base, that is the A and the B, is a 1:2 something. And then we know that the volume of our base is what? Who knows the volume of our base? Who knows the volume of our base in this experiment?
25 centimeters
Very
cube.
good, 25 centimeters cube from the pipette, right? So we know that the volume of our base is 25 centimeters cube. Since based on the balanced equation, okay, acid to base is a 1:2 something. That is to say, acid is like half of the base or something like that. So for us to now get the our volume in terms of titration process, okay, we should ensure that our values is about half of our what, half of um um our volume of base. Okay, so this is not going to be giving us 21, all these bigger values. For accuracy's sake, it is going to be in the range of 12 to about 12.5, or in the range of 11.9 to 12.5. That should be the range of our accurate first titer, second titer, or third titer. Should not be getting big value, because the ratio of sulfuric acid to sodium hydroxide is a 1:2. Assuming it's a 1:1 something, we can be getting uh titer value for our acid to be maybe that 21 something, okay, within that range of 20s, but in this case it's going to be like half of this, just as one is half of two. All right, so now if we look at our rough is quite bigger than the first title, second title, and the third title. I remember what I talked about concordant values. That is the value of our titles that we're going to be using should be closely together, at least a difference of 0.2, not more than 0.2. And that is what we have here. So to get our average acid, our average volume of acid, so that is the A, volume, okay, rather average volume of acid will be, which is actually our VA, okay, calculated VA is going to be equal to title 1, title 2, and title 3. Now we are going to see it as 12.50. Ensure you make it ensure you make it in two decimal places. So don't just write 12.5, 12.50. You add the zero at the end. Please remove this thing here. Plus 12.60 plus 12.50 again. These are concordant to each other, okay, because it doesn't exceed a 0.2 difference. Now all divided by 3. By the time we multiply, let me multiply. So we'll have 37.6 divided by 3, which will give us equals to 12.53 centimeters cube. Now, observe that we are making use of all these values here, right? Because this is the total. And how do we get the total? Final minus initial. Okay, so begin with what you are adding and subtracting. Good. So we have gotten our A answer. I hope no one is confused. I believe no one is. Now the B says we should find the concentration of solution B in mole per dm cube. Concentration of B in mole per dm cube. That is the concentration of the base. And how do we find the concentration? That is where I brought these formulas. We have formula A and this second formula B. These are the two formulas you should have in mind when looking for concentration, okay? Now, is it just these two? Yeah, just these two for now. These are the two formulas you should have in mind. Now, I told you that when okay, this Ca is concentration of acid, Cb concentration of base, this should be volume of acid, Vb volume of base, then Na and Nb, their mole ratio. Like in this question now, the ratio of acid to base is 1:2 based on their coefficient. Okay, so Na and Nb are coefficients. All right, now how do we now know which of the formulas we are going to use? They said our answer should be in mole per dm cube. That is key. All right, that is a key way for us to get our answer in this case. So that is our B. This is how we solve our B. So for our B, um, concentration of solution B. So if we use this first formula, okay, this first formula of CaVa, CBV is not going to work for us. Why is it not going to work for us? Okay, we know the value of Va, volume of acid, to be 12.53. We've just calculated it. We know volume of base to be 25. We know that. We can get the mole ratio from the equation. Okay, but we don't know what Ca is in mole per dm cube. So we need that value of Ca in mole per dm cube for us to be able to calculate Cb, concentration of base, in mole per dm cube. So because we don't know the concentration of the acid in mole per dm cube, we can't find that of base in mole per dm cube using this formula, this first formula. That is why we'll now resort to the second formula, because our question did not give us concentration of base of acid in mole per dm cube, so we don't have that information. So now we are going to resort to the next formula, which is molar concentration is equals to mass concentration divided by molar mass. Were we given mass concentration, molar mass, we can always get that. Are we giving mass concentration? Yes. Remember I told you mass concentration is measured in gram per dm cube. Okay, and we're given an equation that says B is a solution, is a sodium hydroxide solution containing 4.0 gram per dm cube of sodium hydroxide. That is mass concentration of base. So we can use the second formula to get our B. Now, take notes. Gram per dm cube is the unit for mass conc. Mole per dm cube is the unit for molar conc, concentration, okay? So this here is mole per dm cube, but this here is mass per gram per dm cube. Mass is in gram, you know. Then this CaBa, I'm sorry, CaCb, they are in mole per dm cube. So whenever you're being told to find molar concentration, to find concentration in mole per dm cube, okay, you go to your question. If your question give you value of mass concentration in gram per dm cube, you're going to use the second formula, because you will just fix it into the equation. You already know what mass concentration is, and you can definitely calculate molar mass on your own. But for this first formula, you would need the mole concentration of one of them at least in mole per dm cube before you're able to use that formula. But we are not given any mole per dm cube concentration in the question. That's why we can't use formula A, the formula 1. We'll have to use the formula 2. Are you people understanding? Do you understand? Winner does understand, and that's a good sign. Now, that is to say, which of the formula are we going to use now based on all said? Is it the first or the second formula? The what? Very
Second
good, the
formula.
second formula. So when we use the second formula, we would say our molar concentration in mole per dm cube is equals to mass concentration of base. Remember, we are dealing with base now, strictly. It's the first formula that will be rationing between the two, acid and base, acid and base. This one now we're dealing with base. So gram is 4, mass concentration is 4 gram per dm cube, okay, divided by molar mass. Molar mass of what? Of sodium hydroxide. I believe your exam question will also give you molar mass of everything, molar mass of sodium, and aside that, it should be something you already know. Okay, because these are common elements. Sodium is 23, oxygen is 16, hydrogen is 1. So we have 20, 30, 40. So our molar mass is 40. Unit for molar mass is what? Sorry, gram per mole. Okay, so when we divide this, we're going to get equal to, now 4 divided by 40, that would give us 0.1. Okay, and then gram will cancel out gram, right? And then we would have mole per dm cube. Let's not go into the mathematics of what is happening here when this cancel out this, but this is what you get. All right, so we have answered the B to be 0.1 mole per dm cube. Now the next question says the concentration of solution A in mole per dm cube. Concentration of A. How do we get the concentration of A? We'll go back to these two formulas. We are definitely going to be using one of them. Okay. Now we already have concentration of base, right, in mole per dm cube. And so we can easily and comfortably use our formula 1 because we have one of the concentration in mole per dm cube. So we can actually safely say we use the formula 1 when we have one of the concentration in mole per dm cube. And we use the formula 2 when we have the concentration of that particular reagent in gram per dm cube. So since we already have concentration of base to be 0.1, we can actually use the formula 1 to find our concentration of acid. Okay. Now our concentration of acid will be calculated like this. That is our C, right? C, concentration of acid A. Please be jotting down all these things. It's your WAEC questions for this year. So at least even though you don't see exactly this thing in your examination, you will see something close. So you have an idea of what's going on. Now to solve this, we have we want to use the formula CaVa equals to Na divided by CbVb NB. Some textbook has it somehow reversed. By the end of the day, stick with one. They don't confuse you. Now, this formula can further be written as this. Because we are looking for concentration of acid, it's better to just make it the subject of the formula. It's not necessary, but it just depends on you. Making it subject of the formula makes it easier for you to use it to solve. So we can have this old formula, right, to be the same thing as when we make concentration of acid subject of the formula, it will be equal to, we're making it subject by cross multiplying. So CB, VB, NA are all in one plane. CB, VB, NA divided by VA and NB. VA and NB. So this is what we're going to be fixing. So from here, we have our Ca, which is what we're looking for, to be equal to concentration of base is what? Concentration of base. What's the concentration of base? People should tell me. What's CB?
0.1 per dm cube.
Very good. 0.1 times what is our volume of base? VB. Maybe, yeah.
25 centimeter cube.
Very good. 25. Now, what is the number of mole of acid? We check that from the balanced equation. We use the coefficient to represent that. So what is the one for acid? Yes. Number of mole of acid. Anyone there? Okay, the number of mole of acid is based on the coefficient. What is the coefficient of acid in the balanced equation? That's how you know it. It's 1, right? So 1 divided by, let's go back to, so because we winner left, that was why no one answered. Christine and Melody. Melody, you are here. I want to hear from everyone, okay? So divided by volume of acid and number of mole of base, right? So volume of acid, we have it looking at us there. So we have 12.53 times number of mole of base. What is number of mole of our base? Um, Based on the balanced equation again, okay? That will give us, look at the balanced equation. It is what? 2. So we have times 2. So when we multiply all of this, okay, if you are with your calculator, you can do the punching. 0.1 times 25, which is 2.5, okay, and then 12.53 times 2 is 25.6. 25.6. So it's now 2.5 divided by 25.6. All right, so the number of concentration of base is going to be, this is 2.5 divided by 25.6. This will be equal to 0.09, 0.09. Okay, this is going to be in mole per dm cube. Okay, now this is it. Now the next one we have to calculate is the D, the concentration of pure acid. Now when we talk about pure acid, a way we can determine what that is by solving based on the information given to us, not based on the solution. You know, the titration we are doing is a solution of this and that, not based on the calculation or the calculated values we are getting. Okay, it should be based on the information given to us. So the concentration of our pure acid, they said in gram per dm cube. So based on the question, we see that we have our mass of acid. Okay, look at the question. A is a solution prepared by dissolving 3.8 gram of acid. Are you seeing it? That's the pure acid now in 400 centimeters cube of solution. Okay, now all the titration process we have been going through, they are already in solution, so they are not like purely or 100% just the acid. So this whole phrase beginning, the value from the question in the process of dissolving is what will give us our pure value for acid. Okay, now the concentration of our acid in gram per dmq is going to be our mass in gram 3.8 divided by 400 centimeters cube. So that is from our question. So this is D, right? From our question, okay, we have mass of acid to be equals to 3.8 gram, right? And volume of solution is equals to 400 centimeters cubed. But then they said we should find mass, we should find concentration. It's going to be mass concentration because of the units. We'll know that it's mass concentration they're actually looking for. So we should find the concentration of acid, okay, in gram per dm cube. That's what they said. So to get our concentration in gram per dm cube, our mass is in gram, that's fine. But our volume is in centimeters cube, not decimeters cube. So we have to make it in decimeters cube so that we'll get our acid concentration in decimeters, in gram per decimeters cube as well. So this will be 0.4. How do we get 0.4? Remember the conversion we did last time. We say 1000 centimeters cube equals to 1 dm cube. So therefore, 400 centimeters cube will be how many? We'll cross multiply, we have 1000. 1000 times the unknown equals to 400. So we're dividing both sides by 1000. This cancels this cancels. We have 0.4, right? Now, so it's 0.4. So our concentration will be mass, which is 3.8 divided by 0.4. And when we divide this, what do we have? 3.8 divided by 0.4. So we have this to be 9.5. Are you saying it? Are you saying it? So from here, when we get 0.5, 0.5 gram per mole, that tells us that we actually just figured out the mass concentration. They are all concentration, but one is in mass, the other is in molar. Now, the next one, E, is the percentage purity and percentage impurity. Now, percentage purity, that is E. Percentage purity. Please, do you all understand up to this point? All right. Percentage purity is equals to the mass concentration of pure acid. If we go back to the question, we say of solution A, percentage purity of solution A. So we are focusing on the acid divided by mass concentration of the impure acid. So we can liken this to mass concentration of our initial acids before it got dissolved in water, right? Divided by the mass concentration of our impure acid. That is what we calculated, okay, times 100. Okay. So now when we get this, how do you know what the mass concentration of pure and impure is? We already know the mass concentration of pure acid. That's what we just calculated here, right? So which is equals to 9.5. What is that? The mass concentration of the impure acid. The mass concentration of the impure acid is the one we are actually going to be calculating. So we're going to be using the formula for mass concentration. Okay, we know mass concentration is equals to um look at this formula here. Molar concentration is mass concentration divided by molar mass, right? So mass concentration will now be molar mass times molar concentration, or molar concentration times molar mass, right? Good. So mass concentration is equal to molar concentration times molar mass of A. Now this is how we are going to get the mass concentration of impure acid, the calculated one. We can liken it to the calculated one, okay, based on our value of titer and readings and rest. Now what's the molar concentration? What's the molar concentration of acid? We have calculated it before. Now molar concentration of acid, is this Ca? Okay, is this Ca? So it's going to be 0.09, right? Molar concentration in mole per dm cube, 0.09 times molar mass of acid. The acid is H2SO4. Molar mass to be 2 hydrogen plus sulfur is 32 plus oxygen is 16 times 4. So what will be the molar mass? Using times 4 is 64 plus 32 plus 2. That is 98. So our molar mass will be 98. Therefore, our mass concentration of impure, this is of impure acid, okay, is now going to be 0.09 times 98. Okay, you can see this is 8.82. Okay, 8.82 was the unit, gram per mole. Sorry, gram per dm cube. So that is to say we'll fix it back into this equation. Remember, we are looking for percentage purity. So this is going to be divided by 8.82. Let us eliminate this too, because so this is all times 100. So what do we get from here? We have 9.5 divided by 8.8. Okay. We have 9.5 divided by 8.82. Okay, we can actually this our molar concentration. So rather than having 0.09, okay, we can estimate it to be 0.1, okay, and then because of that, this place would now be 0.1. So we would now be having 0.1 times 98. Okay, are you people following what I'm saying? This molar concentration of acid, just as we have that of the base, okay, to one decimal place, we're also going to estimate this. So rather than writing 0.09, we're going to have 0.1, right? Because even our what we divided is 2.5 in one decimal and 25.6 also in one decimal. So let our answer also be in the same having the same energy, right? So the molar concentration here, so that our purity answer will make sense. The molar concentration here will be, this will no longer be 8.8. So you see, all these decimal places have a role to play in giving us good, accurate answers, right? So when 0.1 multiply 98, we don't get this. We get 0.1 times 98. We have 9.8. So this is going to be 9.5 divided by 9.8, right? So when we have 9.5 divided by 9.8, okay, then multiply by our 100. So from what we can see here, we are having 96.9. So this is the percentage purity, okay. Now the percentage purity is 96.9%. Now we're also asked to calculate percentage impurity. So if purity is 96.9, impurity will be what? Therefore, percentage impurity will now be 100 minus 96.9. Okay, that is about 3.06
Now,
percentage.
why do you subtract?
Because we were asked to calculate the percentage purity and percentage impurity. Okay, so this calculation that we did here was calculation based on the formula for percentage purity. Are you seeing it? Percentage purity is mass concentration of pure acid over mass concentration of impure acid times 100. So this answer of 96.9 that we got is for percentage purity, just purity. Now if you want to get that of impurity, the totality of a percentage is 100. So if about 96.9% of it is pure, that means the remaining percentage is not pure. Do you understand? So when we subtract this 96.9 from 100, that's the impure percentage. Now this is for titration. We also have what to talk about. I mentioned that you people will also be doing salt um test for salt analysis process and the rest. So we are going to talk about that in the next class. I hope you all jotted down what we have learned today, and I hope you've learned something and understood all you've learned today. Okay, we now understand. That's good. All right, thank you. Please, if you have a question, you can now ask. Do you have any question? Do you have any question? Okay, I hope everyone has learned something today, and I hope you jotted down for your own good. All right. If you have a question, you keep it for the next class. Bye
No,
bye.
yes,
Okay, thank you.
thank you, ma'am.
You're welcome. Thank you too. Bye.